Today we will talk about adding and subtracting polynomials. There are a few tips to keep in mind when doing so. When adding or subtracting polynomials, it's important to combine like terms. Remember, like terms have to have exactly the same variable with exactly the same exponent. For example, x and x squared are not considered like terms because they're not raised to the same power. For your reference, here are some charts to look at. An example of like terms is 1/3 xy squared, negative 2xy squared, and 6xy squared, because they all have the same variables raised to the same power, x and y squared. Here are some unlike terms, negative 3xy, negative 3y, and 12y squared. These don't have the same variables raised to the same power. The most important thing to remember when combining like terms is that the exponents never get added or subtracted. Only the coefficients, which are the whole numbers in front of the variables, get added or subtracted. Remember, when we multiplied or divided exponents with the same base, that's the only time we ever added or subtracted exponents, but never for addition or subtraction. Let's start with adding polynomials. When adding polynomials, gather like terms and write your final answer in standard form. Remember from yesterday, standard form is when you write it in degree order from the highest degree of a polynomial to its lowest degree. Let's look at an example. 6x minus x squared plus 3 plus 4x squared minus x minus 2. Since I'm adding these three terms to these three terms, having the parentheses when you add doesn't really change anything. So the first thing we can do is drop the parentheses. So we have exactly the same problem, just without the parentheses. Notice that I've highlighted my like terms, 6x and negative 1x, negative x squared and positive 4x squared, and positive 3 and negative 2. Now we're going to start adding these polynomials. Be sure to include negatives in front of the variable and the number when you're adding. I like to start, as a tip, always with the highest degree first. This way I don't have to worry about writing it in standard form in the end. So negative 1x squared plus 4x squared is 3x squared. 6x minus 1x is 5x. And 3 minus 2 is 1, making my final answer 3x squared plus 5x plus 1. The reason we can't go any further is because we no longer have any more like terms. You try an example. X to the fourth minus 4x plus 3 plus 3x to the fourth minus 3x minus 5. You can pause the video here. You should have combined x to the fourth and 3x to the fourth, making that 4x to the fourth. Negative 4x and negative 3x, giving you negative 7x, and 3 with negative 5, giving you negative 2. Hopefully you started doing this in degree order, and if you didn't, you can always just switch things around so that they're written in standard form. Now let's talk about subtracting polynomials. This is a little bit different because when you subtract polynomials, you have to remember to distribute the negative sign because this definitely changes your answer. Then you can follow the steps to adding or subtracting or adding polynomials. So here's an example. 5x squared minus 4x plus 1 minus the quantity 8 minus x squared. Now it's not just 8 that's being subtracted, and it's not just negative x squared that's being subtracted. So it's very, very important that you distribute this negative sign because this will change your answer a lot. Now you can remove the parentheses after you distribute, and you have 5x squared minus 4x plus 1. Then you end up with negative 8, and a negative make positive x squared. Starting in degree order, now I can combine like terms. 5x squared plus 1x squared is 6x squared. Negative 4x can't be combined with anything, leaving it just negative 4x. And positive 1 minus 8 is negative 7. Now you try one. Negative x squared plus 3x minus 4 minus negative 3x squared minus 6x plus 2. Pause the video here. You should have first distributed the negative sign to all three terms because the whole thing is being subtracted from the first quantity. Then you have negative x squared plus 3x minus 4. Negative and a negative turn to positive 3x squared. Negative and a negative make positive 6x. And negative and a positive make a negative. Combining like terms in degree order, negative 1x squared plus 3x squared is 2x squared. 3x plus 6x is 9x. And negative 4 minus 2 is negative 6. And now let's try one final problem. 4x to the fifth plus 2x squared plus 8 minus 4x squared minus 3x squared plus 6. Pause the video here. The first thing you should have done was distribute your minus sign to all three terms. Then you could drop the parentheses, leaving you with 4x to the fifth plus 2x squared plus 8 minus 4x squared, positive 3x squared, and negative 6. Now if you see, there's nothing I can combine 4x to the fifth power with and negative 4x to the fourth power with because these exponents do not match, so I have to leave them as is. 2x squared can be combined with positive 3x squared, giving me 5x squared, and 8 minus 6 is positive 2. So this is 4x to the fifth power minus 4x to the fourth power plus 5x squared plus 2. And to really test your memory, we can call this a quintic polynomial because it has a degree of 5.